Welcome everyone, and thank you for joining us for this ITE Learning webinar, Micromobility, Data Collection and Processing, Considerations for Policy Regulation and Data Privacy while using the data meaningfully. My name is Zach Pleasant, and I'm the ITE IT Senior Director and will facilitate today's webinar. Before we get started, I'd like to go over some housekeeping items. This webinar will be recorded for ITE's archive, and the recording will be available within a week after the webinar ends for all registrants. All registrants have access to the webinar for 30 days. There will be a Q&A period at the end of the webinar during which the presenters will answer participant questions. We do encourage you to type your questions into the questions pods as they occur to you throughout the webinar instead of waiting until the end. Your attendance in this webinar does include a complimentary participation certificate upon completion. If you wish to receive the 1.5 PDH credits for your participation in today's webinar, there's a processing fee to receive that PDH credit certificate of $15 for members and $25 for non-members. Use the Files pod to download the course presentation from today's webinar or visit the Resources tab of the Events page in the Learning Hub, where they will also be updated. Here are the ways to participate in today's webinar. The question pod. Type your questions here for a Q&A at the end of the webinar. We will try to answer all questions within the time allotted. Depending on the volume of questions, we may extend the webinar for up to 5 minutes. If you have multiple attendees at your site, please have the additional attendees in the room share their questions for you to type in on their behalf, and we hope you enjoy today's webinar. Once again, welcome everyone and thank you for joining this ITE Learning Hub webinar, Micromobility, Data Collection and Processing, Considerations for Policy Regulation and Data Privacy while using the data meaningfully. This webinar is being presented as part of a series partnership with the National Travel Monitoring Exposition and Conference, or NATMEC. This session will provide an overview of the regulations that have rolled out in cities around the world, key issues that have been raised about privacy concerns, and potential solutions for moving forward. Next, a study using data from an e-scooter system in Nashville, Tennessee will show how the GPS trace data from these trips can be used to understand micromobility use. Through a big data approach, spatio-temporal patterns can help visualize popular routes and trip duration, distance, and start times. Today's learning objectives: attendees will learn and become familiar with micromobility regulations used in many cities to address data access and privacy concerns. Learn best practices to protect geospatial data through license agreements, privacy policies, and technical methods for city planners and policymakers to use these data without compromising privacy. Understand how city planners, researchers, and policymakers can benefit from using and analyzing micromobility data to reveal travel patterns. Now, I'd like to introduce our presenters for today's webinar. Stephanie Secchi, a Mobility Partnerships Manager at Populous, and Nitesh Raj Shah, Graduate Research Student at University of Tennessee, Knoxville. And today's moderator, our Q&A moderator, will be Sarah Worth O'Brien, Senior Research Associate at UNC Highway Safety Research Center. Now with that, I'd like to hand things over to kick things off with Stephanie.
Hi everyone, this is Stephanie Secchi. As Zach said, I am a Mobility Partnerships Manager at Populous, which means that I work with the cities who are our customers, help them get acquainted with our platform, and work with them as we further develop our solutions. I also am a former researcher, so I work on research projects that we do at Populous, including currently a couple of safety-related e-scooter projects. So I'm going to be giving kind of more of a general overview on micromobility data, and Natasha is going to follow me with a specific case study, but I think they're pretty complementary in terms of what we're covering. So I will start kind of with just an intro to Populous, pretty quick. In case you don't know who Populous is, we are a software as a service company. We work with cities to be able to manage better their data from their shared mobility programs. We securely host the data for them. We analyze the data from the world's largest mobility operators, and we deliver our solution in over 80 cities. And our solutions really help cities to be able to update and communicate new policies in this very rapidly changing transportation ecosystem. And I'll give some specific examples at the end of the types of policies and the types of analysis that we see in cities. So you all probably know there has been a rapid expansion of shared mobility services. I wasn't able to update this timeline. If I had, there would be more companies on this timeline, especially in the last couple of years, the rise of micromobility. But also in the past year, there's been a lot of change with some companies merging, some no longer in existence. But I think the takeaway is that there have been a lot of changes in the shared mobility space. And with that expansion of services, a need for cities to better be able to understand how these services are impacting movement around their city and how people are using them. And access to data from mobility operators is really important to understand that. As these various shared mobility services were introduced in cities, many were frustrated by the lack of information that they had about these private services, and they weren't able to really answer the questions that they had about whether they were improving safety, how they might be changing traffic patterns, whether or not these additional services were expanding access to the underserved. And while this transformation is very beneficial in terms of, it could be very beneficial in terms of expanding options and maybe even with some environmental benefits, we have to remember that these private companies are not naturally necessarily incentivized to reduce traffic or improve safety. These are, broader societal goals and ones that public agencies are primarily responsible for measuring our progress towards. And this is the fundamental reason that cities have been asking private operators to share this data, to be able to then measure do they reduce transportation-related injuries and fatalities? Are they improving availability and accessibility of transportation services more broadly? And are they providing or prioritizing efficient use of public space and reducing transportation energy use and climate impacts? Basically, are they helping cities to reach these broader goals? The arrival of e-scooters kind of changed the game with mobility data. And I think at first it was hard for people to take scooters seriously, but they really did change the way and the context for mobility data sharing in cities. I think many cities had learned from prior experiences with private mobility services like Uber and Lyft, where most cities had very limited information about these services and how they were changing the way that people were moving around cities. And cities were kind of preparing for a wave of dockless bike share, and instead what they got was a wave of dockless scooters. They kind of adjusted policies that they had been planning for dockless bikes to work for scooters. And I think what operators found and also cities found was that it was much easier to regulate these types of services because it's hard to operate these smaller vehicles without coordination with the city. You have to use sidewalk space. They're much smaller, so they're easier for cities to impound if there are issues. And they're mostly owned by a single company. And that creates just a different dynamic than there had been in the past. And it kind of coincided with the release of a new data standard that then was tested on these shared mobility devices. And so the data standards, and that is, I'm specifically referring to MDS, but there are two data standards that typically now, maybe a couple years out, that we see cities require of operators who are in their cities. And these are the General Bike Share Feed Specification and MDS. So the General Bike Share Feed Specification or GBFS, was initially created through NHTSA for docked bike systems, and essentially tells users where there are available bikes for rent. It was adapted for dockless vehicles to do essentially the same thing, except we're not talking about dock stations, we're talking about individual vehicles. So it's I would say, it's a great data set because it gives you a live look at what's happening, where vehicles are now, how many are available for rent. It doesn't necessarily tell you anything about the trips taken, but that's kind of where the mobility data specification comes in, which was really launched kind of at the same time that scooters were hitting the streets. It initially came out of LADOT, but now is under a separate organization called the Open Mobility Foundation. And the MDS, the Mobility Data Specification, has more detailed data. It was built for operators to communicate with cities and cities to communicate back. It includes vehicle status changes, so updates on the vehicle state, whether it's available or needs to be picked up for maintenance, it's been dropped off by an operator, things like that. And also defines the formats for sharing trip data, which includes the locations of the start of a trip, the end of a trip, as well as breadcrumb GPS trace data. And like I said, typically now we see cities are pretty familiar with the data standards. If they're kind of going to launch a program, they've usually heard about them. Maybe they don't know all the details, but they'll find out about them, and they usually include them in their requirements with operators. One of the slide behind, sorry about that. So some of the approaches that we see with mobility data sharing, there are kind of three ways that we generally see. So I think the traditional model, what we had seen before MDS, is that an operator would provide aggregated data to the city, maybe on a monthly basis about the program. In this case, the burden was really placed on the operator to provide that information, and the city bears little risk because within that data set, it's aggregated, typically no sensitive information, and the city doesn't have to store, huge amounts of data. But the cons there are that maybe the data is not as flexible in terms of being able to do different types of analyses or analyses you haven't even thought of yet. A second approach is this middle one, which is data delivered through a trusted third party like Populous. In this case, Populous or other third party ingests the data on behalf of the cities and aggregates it. We store the data securely, and the city staff access already aggregated data that's been, the sensitive information has been removed. So in this case, the city also bears little risk since they're not bringing in raw data themselves. They're accessing already aggregated data. I think I forgot to mention on the last slide too, but for both MDS and GBFS, the data comes in through APIs, which basically means that once whoever is ingesting the data is connected to data feeds, it automatically will continue to bring in the data. I think one of the nice things about using a third-party aggregator is that there tend to be issues with data feeds. Since we work with all of the large and small operators in the US, we often see those issues very early and can address them pretty quickly. And that can be a pretty challenging process sometimes. So the third option is then a city brings in the raw data themselves in the disaggregate form. This allows them to have more flexibility and direct access to the raw data, so they can do whatever they want with it. It gives them the freedom to do that. And it may be that a city may wish to do that because they want to kind of build up this technical expertise in-house, or maybe they have a team built up that they feel can handle this well. We usually only see, I would say, larger cities to bring in the raw data themselves, just because it's a lot of data that you have to keep secure. And again, it gets messy when data feeds change or are updated or there are errors with them. But I think in general, what we see is kind of a combination of these. So even a city that may be directly receiving raw data, they may also use an aggregator to do the kind of general analysis, and maybe for the staffers that don't need the raw data but just want the aggregated data, that's another good option. And they may even ask operators to provide monthly data as well. But it's kind of a combination of those. And we kind of list these as least risk to most risk in terms of the types of data that cities are then responsible for. In terms of privacy and data security, there are concerns. So with the trip data coming in through MDS, it does include the locations of the starts and ends of trips, as well as that breadcrumb GPS trace data for a route, and that can be considered personally identifiable information. What we do to aggregate that data is that you can't identify an individual trip, but you can still see volumes of trips across road segments. Newer policies such as GDPR and CCPA are changing the way that companies and other organizations are to treat this type of data. So location data can be considered personally identifiable. And we've seen that some data share agreements are moving forward without guidelines on data security, processing, storage, retention, and those are very important pieces to ensuring that data is kept secure. But of course, we are kind of balancing this need of the public sector needing data to be able to understand what's happening on the streets, make informed policy decisions, but also still wanting to protect privacy. There are a few things that we think about as a third-party aggregator and more broadly, but securing access to the data is important, and that's one of our top priorities is keeping the data safe. And then we only provide this aggregated data to city staff, and they don't have to worry about kind of working with this raw data. Having data license agreements in place is very important in terms of kind of scoping out what can be done with the data, how it can be shared, what happens to it for a certain period of time, or if your agreement with an operator or a city ends. Using a third-party solution we think is a good solution, but that might just be me tooting my own horn. And then the last one I think is really important, and what I spend a lot of time working on with cities is focusing on how to take this information and this data that they now have available to them and guide decision making. So what do they need to know in order to answer the questions that they have? And I think that's the key piece of it, right? How can we use this data to inform policy decision making? So I would say that there are lots of commonalities between programs across cities. They usually have pretty similar goals and as well as implementation. They vary in terms of the specific policies and how they choose operators. So some have a licensing process, some have an RFP process, and that kind of varies, but once the programs are started, the core of the programs are pretty similar. And in terms of how they use data for their micromobility programs, I kind of lump it into three categories, the first being program management and compliance. And that's, I think, where most cities start. It's making sure that once a program starts, that they're able to validate that the operators are complying with the policies that they agreed to. So that could be around vehicle caps, so the number of vehicles that are in the city. It can be around specific policies like parking, no ride zones in geo-fenced areas. They can use it to communicate better with operators because they have more insight into where operators are dropping off scooters, where people are taking rides. And then even, especially at the start of a program, when they receive complaints from the public, they're better able to answer and address those because they have insight into what's happening. So they can go and look into the data and say, oh, we got a complaint about this. Let me see what's going on. Let me see if I could identify the issue and provide some solution. The second piece, which is reporting, I think comes maybe a little bit later. This is usually a mid to end of year program evaluation. The data is really valuable in this case too because it is able to give you the summary of the program. How many trips were taken, where were they taken, were the policies, did they work as a city had planned, and the data can provide you all of that even in this aggregated form or not in the raw data form. It obviously takes some work to get to that reporting and to get it aggregated in the way that you would like. And even not just the end of mid-year, but if there are other internal reporting or tracking or questions that cities receive, they can at any point access the data and be able to answer those questions. I think that's pretty powerful in kind of determining whether the program is doing what they want it to, determining the future of the program. They can do it in a way that is well-informed. And finally, maybe the longer-term look is this data can be used for planning purposes. So You can use it to evaluate maybe current infrastructure that you have for in terms of like a bike network, or it can inform future development. And it really can be useful beyond just the scooter part of the program. And I'm going to give a couple of more specific examples of types of policies that cities look at. So the first I mentioned before, but I think where a lot of cities start is they just want to know how many vehicles are out there when a program launches. And often there is a cap on the number of vehicles that can operate per operator within the city limits. And you can do that with the data. You can very easily count the number of vehicles to ensure that they're meeting the requirements of their agreement the operator signed. If there are issues with clutter on the sidewalk, to be able to adjust that and address it. If it's possible that more scooters are doable, then being able to have the data to back up that decision as well is important. Equity analysis I wanted to talk about briefly too. I think this isn't common in all cities, but many cities are thinking about and have a priority for thinking about how shared micromobility might improve access to transportation solutions. And so they'll often have an equity requirement in their program. Usually it looks like a percentage requirement of the fleet number of vehicles to be deployed in a certain area by a certain time. And that's pretty general. It can be pretty specific. Like in San Francisco, they've kind of split the city up into different areas. And then in each of those areas, the operators need to have 70% of the allowable vehicles there, 70% of the time across 70% of the area. I think it's 70%. It's a number like that, but it's very specific. And it's meant so that even within an area of the city, operators aren't going to just put their scooters all in one location where they know they'll get rides, but rather it forces them to distribute the vehicles more broadly across the area. And so I think that's a pretty unique model in terms of equity requirements. Baltimore has one where they have equity areas, but they're rather small because they've kind of targeted areas where they want operators to put vehicles. And then other ones are kind of these broader areas. But I think having the data allows cities to be able to evaluate their equity policies and then maybe make changes according to how well it's working. Is it meeting your needs? Is it not? But at least you have a way to make that assessment and adjust as necessary to make sure that you're meeting your equity goals. There's a lot of performance evaluation. I just use utilization as an example here, which is trips per vehicle. It's a measure that many cities are using to determine whether operators can add more vehicles to their fleet. So there's a high enough utilization rate, maybe that indicates that there's space and demand for more vehicles out there. But there's really a lot that you can do. That's just one example of performance evaluation. The parking and policy enforcement, I think, is pretty common in cities, especially I think now that some cities have had scooters for a while and they're thinking about kind of what are the next steps and how we make the program work better. You can use the historical data that you receive from operators to, for example, look at all of the parking events. This is an example from Arlington County. You can they looked at the historical parking events and then identified areas where they could put in parking corrals on the street. And then they can communicate those to the operators to say, hey, let your users know that we have these parking corrals and they should end their trips here whenever they can. And then you can go, as you start to collect new data after the corrals are put into place, be able to evaluate the use of those parking areas. So it's really kind of a full service. You can look at historical data to make informed decisions, and then you can evaluate how well you did, and then adjust accordingly. And if you're using a platform like Populous or you have your own in-house solutions in the city, you can really create these spaces digitally as well and communicate them easily to the operator to incorporate it into their app. Other types of policies that we see in addition to kind of preferred, what we call preferred parking areas like parking corrals, We see a lot of no parking zones or no parking areas and no riding zones. We have overnight restrictions, slow ride zones. I'm trying to think of some other common ones. I think those are pretty common. If you have questions about other policies, I'm happy to go into that. But all of the policies that we have seen can be evaluated using these data sets. The final example I was going to give is route-based analysis. So with the GPS trace data that comes through MDS, cities are able to see where are the common routes being taken on the shared micromobility devices. And as I said, we aggregate the data. So what is shown on our platform for routes analysis is aggregated route data. You can't see an individual trip, but you can see it by road segments, the trip volumes. And that still gives you an idea of where the popular routes are without potentially working with sensitive route data. And this we see as valuable to evaluate, impacts of new infrastructure or when you're developing your infrastructure to kind of inform those decisions. And outside of MDS, I just wanted to mention, and outside of GBFS and the GPS-based data collection, we found that surveys also provide a lot of valuable information. So these are some results from a survey that we did in the town of Brookline in the Boston area. And survey data can really answer some key questions that GPS data can't. So GPS data can't tell you why people use a scooter. Where were they going? You can kind of make some assumptions based on location, but it's challenging. It's nice to have some validation external to that. So survey data can help illuminate why people are making the travel choices they did and maybe better answer questions about mode switch and potential benefits from an environmental perspective. So I like to say that, it's a good supplementary data collection. Then the last point that I wanted to make was on the value of having this data. So outside of just the micromobility program and being able to validate what's happening with your program and evaluate whether it's accomplishing your goals, the data is useful outside of that context as well. So this example on the slide here is showing spin scooter trips. Oh, it's not, it's a persist switch. I just realized that it's not switching. There are two images that it's supposed to switch between. Essentially, we worked with Spin to look at scooter trips in San Francisco in 2020, where we were comparing March 2020 to August 2020. And in that time, San Francisco had implemented some flow streets. Let me try my pointer on. So the red line here, this is one of the flow streets on Page Street. This kind of squiggly line is another one, which is in Golden Gate Park. And all of the teal hexagons behind that are trip counts. And basically, if it was moving, you would see that a lot of trips between March and April, and it was March before shelter in place, I'm sorry, March and August, March before shelter in place in August 2020 had shifted. So off to the right here is a little bit further right is kind of the financial district downtown area. And here's Golden Gate. If you keep going in that direction towards the left of the screen is Ocean Beach. And we see a lot of shift between trips that were happening more on this side of the city that have kind of transferred to this western part of the city. And this is information that the city didn't necessarily have prior. It doesn't tell you all of the trips that have been taken on the flow streets, but it is one component of it that the city might not have had access to before. So I think having this type of data is valuable, not just for the program itself, but for broader initiatives that are happening at the city. So that is my last slide. Thank you all. I'm happy to answer questions. I know I kind of covered a lot, and you may have specific questions, so happy to answer anything that comes up in the question box. And now I will pass it on to Nitesh.
Thank you, Stephanie, for a very informative presentation on micromobility data. Hi, everyone. I'm Nitesh Shah, and I'm a PhD student at University of Tennessee. Today, I'll be presenting a case study on the use of micromobility data. Before I begin my presentation, I want to acknowledge the contribution of my colleague Jing, Dr. Han, and my supervisor, Dr. Cherry, for their contribution on this research. In past several years, e-scooters are gaining popularity in the United States as well as around the world. As you can see in the picture, e-scooters are two-wheeler electric motor operated devices which can go up to 20 miles per hour. In 2019, there were 86 million e-scooter trips in the United States. And this is an increase of more than 120% as compared to 2018. E-scooters are emerging because they were not the major mode of transportation a few years ago. They are disruptive technology because they make us reconsider how we plan for transportation system. For example, we might need to consider electric scooters as one of the road users while designing traffic signals. Stephanie went thoroughly over high-level policy questions, but I'll briefly go over them as well. For safety, we can think about does e-scooter crashes occur at specific time and location? For sustainability, are e-scooters contributing less or more in pollution? For parking, where should we build e-scooter parking location and how big? For mode shift, which modes are e-scooter replacing? In addition to this, there are other policy level questions such as equity. But behind all that, there is a fundamental question: when, where, and why people use e-scooters. Researchers have taken different approaches to answer this question. First method is to survey or do an observational study. This is very common among the pilot evaluation projects like City of Austin. Basically, they intercept e-scooter riders and ask questions like, why are they using e-scooters, or what mode would they use if e-scooters were not available? This pilot and survey-based studies are informative, but they only represent a small proportion of all trips. And they only capture e-scooter users' activity at certain time during the survey period. Another way is to evaluate micromobility data. Earlier studies used descriptive statistics to plot where and when e-scooters were being used to explain the user's pattern. Descriptive choice models can explain the choice of people using e-scooter versus other mode of transportation like bike share. Regression models are good at explaining the factors influencing e-scooters such as socio-demographic and built environment. Spatial regression models adds to those traditional regression models by including spatial component. This research complements these existing research by identifying e-scooter users' patterns using spatial temporal analysis of micromobility data. Basically, we evaluated all the scooter trips that occurred during a year and took a combination of principal component analysis and key means clustering to identify the patterns. Before I explain the methodology, I want to spend some time explaining the data. We got e-scooter data from Nashville, Tennessee. The city of Nashville requires all the e-scooter operators to submit the scooter data under Shared Use Mobility Device or SUMD dataset. There are three datasets within SUMD: trip summary, device availability, and parking compliance. For this study, we just used trip summary data. A sample of trip summary data is illustrated in the slide. Basically, there are origin and destination related variables like time, date, latitude, and longitude. The trip level information can be trip ID, vehicle ID, trip duration, and trip distance. We also have had route level GPS path data. We extracted a year-long trip data from September 1, 2018 to August 31, 2019. And after basic cleaning, we had over 1 million trips. Basic descriptive statistics can give a sense of general e-scooter users. In the top figure on the right, you can see e-scooter users by time of a day and a week. Y-axis is average e-scooter trips per hour, and x-axis is the time of a day. All the days of a week are stacked horizontally. As you can see, there is only one peak in the evening. It doesn't resemble a normal commuting pattern, which has two peaks, morning and in the evening. If you compare the scooter trips over a week, weekends has higher scooter trips, mainly from Friday to Saturday. And among that, Saturday evening has highest e-scooter use. The figure on the right is e-scooter users over a year. The y-axis is daily trip volume, and x-axis is days across the analysis period. As you can see, the warmer month has higher scooter trips. The average trip distance of e-scooters are 0.72 miles, which is a bit longer than walking, and it might be less for a car trip. The average trip duration is 17 minutes. This slide presents a high-level framework of the analysis. Basically, there are three components: input data, unsupervised machine learning, and post-processing. First, with the input data. The parallelograms in purple represents data sources, and yellow rectangles represents the variable we used. As explained in slides above, we extracted trip-level data from Nashville's SUMD dataset, and trip-level informations were basically trip distance, trip duration, information related to scooter start time, mainly start time of an hour and start time of a week. Then we extracted weather data from Global Historical Climatology Network, and we extracted daily average temperature and daily average precipitation. We also linked built environment characteristics at the origin and destination of each e-scooter trips using Nashville's activity-based model and Google Map point of interest data. For built environment, we used population density, employment density, land use type, parking capacity, intersection density, and entropy, which is a mixture of different destinations obtained from Google Maps POI. We also created some variables. Among them, route greatness is an important one, and it's illustrated on the right margin of the slide. Basically, route greatness ratio is a ratio of Euclidean distance between origin and destination, which is also a straight line distance, to the actual path distance between same origin and destination. Values of route greatness ratio lies between 0 and 1. The value towards 1 being the shortest path possible between the origin and destination, and value towards 0 is the longer path between same origin and destination. The principal component analysis can be helpful for explaining the factors influencing e-scooter trips. Basically, principal component analysis is transformation of variables into hypothetical plane known as principal components, or PCs. Basically, we were able to extract 11 PCs in the data, and these 11 PCs explained 90% variation in the data. So basically, we were able to reduce more than 30 variables into 11 variables for analysis. The figure in the right represents the histogram of loadings of each variables on individual PCs, and they also indicate the correlation between variables and the PCs. The darker color of red and blue represents stronger correlation. You can see time-related variables, mainly weekends and evening trips, have very strong correlation. The land use variables like proportion of a central business district in origin and destination, as well as urban land use type, also showed strong correlation, as indicated on this heat map. Similarly, we also found a correlation between temperature and route directness ratio. We used this species to identify 16 optimum clusters. So I want to go back to explain more about these clusters in this methodology slide. So basically, we used the principal components to identify clusters in k-means cluster. And in post-processing, we used siloed score to identify optimum number of clusters. In this case, it was 16. We interpreted each individual clusters using the aggregated value as well as plotting them in a graph. Some of the clusters were similar among each other. So we further grouped the 16 clusters into 5 individual groups. These groups were based on similar attributes of start time, origin and destination, land use, and route directness ratio. For these group clusters, we named them as users group clusters. This table shows the distribution of e-scooter trips among each groups, as well as a summary of general attributes. The red color shows lower values and blue color shows higher values among these groups. First group is daytime short errand clusters. These are very short e-scooter trips, but they are very direct in origin and destination as indicated by route directness ratio. Most of these trips occur during the weekdays. The second group is utilitarian groups. These are the longest e-scooter trips among all those groups and also among the direct path among origin and destination as indicated by route directness ratio. This trip also occur in the weekdays. Third trip is evening social trips. These trips mainly occur nearby restaurants and they are mostly during the evening time of the weekend. The fourth group is nighttime entertainment district trips. They usually occur around bars and nightclubs in Nashville. They occur almost equally in weekend and weekdays. The last group is recreational trips, and these trips have the longest path between origin and destination as possible, as indicated by route directness ratio. Most of these trips occur during the weekend. Next thing we did was we evaluated the spatial and temporal distribution of each of these users group clusters. This slide presents the trip distribution of each users group clusters over the month. The y-axis is average daily trips and x-axis is days throughout the analysis period. The line plot is 21 days average of average daily trips of each groups. I want to highlight 3 main findings in this year. First, the daily average trips increased in summer months for all of the users groups. Second, the number of e-scooter trips on each users groups were influenced by specific events in Nashville. For example, with daytime short errand trips increased and decreased with start and end of spring semester in the Vanderbilt University. Similarly, during the NFL draft in Nashville, there appears to be increase in trips for some of the users group, mainly nighttime entertainment district trips and recreational trips. And finally, comparing the e-scooter users volume at the beginning and the end of the study period, we found that for each users group, the scooter activities increased in general. We also found a strong spatial distribution for each of these clusters. The map in the left-hand side represents the boundary based on land use for Nashville. Basically, we categorized the land use for each for the grids of each e-scooter activities into 5 labels, mainly commercial, downtown, park, Vanderbilt University, and remaining other as others. The circular chord diagrams on the right illustrates the flow of e-scooter trips among these land use categories for each users grouped clusters. In this slide, there is just daytime short errand and nighttime entertainment district trips for illustration. As you can see, the flow of e-scooter trips is somewhat uniformly distributed among all the land use category for daytime short errand trips. Comparing that with nighttime entertainment district trips, the flow of e-scooters are mainly on the downtown area. We also found similar spatial patterns for other users group clusters. Based on the findings of the results I presented, we can summarize this research into 5 key takeaways. First, we were able to identify 5 distinct e-scooter users patterns based on their users. Second, 75% of the e-scooter trips were not nighttime entertainment trips as expected in Nashville, because Nashville is one of the tourist destinations. Similarly, we also found that only 20% of those e-scooter trips were purely recreational in our data set. All this is to say that e-scooters are not just used for recreational. We also didn't find any commuting patterns in Nashville. In general, the number of e-scooter trips for all these user groups increased over the year, which also aligns with increasing popularity of e-scooters. In general, e-scooter trips are found higher during the weekends and summer months. There are several ways that future research can build upon this study. The first one would be to validate the users group clusters using the survey data. One option can be directly linking the survey results with the actual micromobility data and using techniques to expand that labeling to all the micromobility data using semi-supervised learning. In this study, we only used built environment information for origin and destination of e-scooter trips. Future studies can include built environment at route level. And finally, the results of this study is specific to Nashville, and they might not necessarily be true for other cities. Using data standards like MDS and using similar analytical framework, we can easily expand this study to multiple cities and do a comparative analysis. And these are the references I used in my slide. Please feel free to ask any questions or even reach me out from the contact information in the slide. Thank you.
All right. Sarah Worth O'Brien will facilitate today's Q&A. So Sarah, I'll go ahead and pass things over to you.
Yeah, and I'll just start by saying I don't see any questions in the question pod, so feel free to type in your questions for either Stephanie or Nitesh. I did take some notes, and I've got some questions of my own, so I'll just start it out by asking Stephanie. So I know the slide where you were starting to talk about the 2 different data formats wasn't showing while you were talking about it, so maybe there could be some confusion there. But I was kind of wondering, could you talk a little bit more about those two data standards and how they ensure privacy or security concerns are addressed? I know you talked about some of the standard formats for the two different data standards, but I'm wondering specifically how they address privacy or security issues.
Sure. Yeah, sorry about that. I'm not sure that I would have covered that clearly on that slide anyway, so I think that's a good follow-up question. I'll start with the easier one. For GBFS, which is the General Bike Share Feed Specification, there is less sensitive data because it doesn't tell you where trips are being taken. It's really just showing you the location of available vehicles. There, I think, are less privacy concerns. I know that one of the things that they do that is relatively new to the standard is that IDs for the vehicles that come through the data feeds are rotated after every use. So you can't really make connections between a single vehicle. Like you can't track where a vehicle has, ended up. You couldn't see where the trip was taken, but I guess if you could connect those IDs previously, you might be able to maybe guess where trips were taken, at least see if you were tracking the data closely enough. But they do rotate IDs now. And there is, I think, just generally the GBFS is meant to be more public facing, so there are less sensitive issues around GBFS. As that standard changes though, that might change as well. But that's my understanding of where it stands now. For MDS, I think it's a little bit different. So the data feeds that cities and aggregators like us have access to that come from the operators are secured, so they're private. You have to get them directly from the operator, and you have to go through multiple steps to access them because the data that comes through MDS is more sensitive because it has that GPS trace data. So when we access data, we have data access agreements in place with operators. We have data agreements in place with the cities that we work with that kind of tells you what you can and can't do with the data. And so, when we pull in data through MDS, we store that raw data securely, and any cities that access our platform don't access the raw data, they access the aggregated data that has removed that potentially personally identifiable information. So it really is on the entity that is ingesting the data, the raw MDS data, to ensure that is kept securely.
Thanks for that clarification. And Nitesh, kind of a follow-up for you. You mentioned that you were using Nashville's shared use mobility device data. I guess I'm wondering a little bit more of the background of that data set and how does Nashville get that data? Do they get it through a third party? Do they get it directly from the operator? What level of aggregation is it in before you were able to access it?
Yes, the data standard for shared mobility, it's abbreviated as SVMD data. That data standard is Nashville specific, and they adopted that while deploying a pilot study within Nashville. So it's not directly related with MDS or GBFS data specification, but it's their own data standard. And I might be wrong, but I think SUMD data standard has more detailed information as compared to MDS data. I think Stephanie might be able to say more about this.
Yeah, so I'm not sure. I've not seen the specific data from Nashville, but based on what you showed in your slides, they look pretty similar, I would say.
Okay. Yeah. And basically, they collect data directly from operators. So each operator has to submit all this data to the city of Nashville, and they basically archive and maintain the data.
Okay, thank you. Another question for Stephanie, or maybe even Natasha. You mentioned different ways that cities can use the data, potentially looking at compliance and enforcement. And I know several cities have had issues with both bike share, but also particularly e-scooters, where they may be parked in a location that impedes the flow of pedestrians or otherwise creates some sort of barrier or is just not in a good location. And I guess I'm wondering, as far as the policy side of things, if you're aware of, what cities are doing if they identify that there's a routine compliance issue. Is that something that the operators address? Are they somehow using that data to identify repeat offenders and, fine individuals? Or what kind of policies have you seen around that?
Yeah, they're definitely, it's working it out with the operators, I would say. So I think and then the operators then have to figure out a way to communicate that to their users and get their users to comply with the policies. I think that's definitely a challenge, and some cities have taken different approaches to how they kind of want to deal with that issue. So some cities that, were initially and continue to be really concerned about where scooters are parked have lock-to policies. So that is when you end a trip, there's a lock on the scooter or bike, and it has to be locked to something. So like a pole or a bike rack that generally places it out of the way. It could still be in the way of some people like exiting a car and things like that, but it's generally meant to keep it out of the way. I think that's one solution, but we haven't seen that in a ton of cities. I know San Francisco has it. I think Chicago tested it out in their second pilot as well. But I would generally say that a lot of it is the cities and the operators kind of negotiating what makes sense, and and how to kind of best communicate from the city to the operator to the users. And I think the cities do place a lot of that on the operators, because there'll usually be something within the agreement that they have that states that scooters cannot be parked in certain locations. So the operators are bound by that agreement. So they have to figure out how to make it work, which is why maybe it doesn't work perfectly all the time. And there are ways for cities to be able to use the data to kind of see where are we seeing clusters of vehicles, and where are we hearing complaints, and being able to like target specific areas and maybe track activity in those areas a little more closely to understand, or to try to better understand what the issue might be.
And are you aware of, do any of the agreements basically require operators to track individual users and potentially like restrict their access to check out future devices, future vehicles?
I don't think so. I've not heard of that. Yeah, I've not heard of that. I don't think I've seen that in a permit. I don't know if operators do that on their own. I haven't heard of anything like that.
Okay.
I know that some of the operators require to take a picture of how you park e-scooters after the ride, but I'm not sure if they analyze that data and like make sure if it complies with the parking regulation or not.
Yeah, that's true. I haven't seen much. That's not the type of data that we bring in through MDS, but I know you're right that some operators do require that, but I'm not sure how they use that or how they then communicate that to cities, because it's outside of kind of the standard data, the data standards.
Yeah, that's kind of interesting. Could be another research project there to just look at the imagery data and see what questions can be answered there. Let's see. So Nitesh, you talked about the data sets that you're using, and maybe Stephanie, this may also go back to you, so I'll let both of you jump in here. But even for data, I guess I'm wondering how raw is the raw data that comes from the operators? Because it seems like if you get true, accurate start and end destinations for trips, that could potentially expose some privacy concerns. And so I'm wondering, how do operators handle that, or how do third-party aggregators handle that? Are the start and end locations, how precise are they, or are they somehow truncated or buffered to protect people's privacy?
Okay, I'll go first on this question. So the data we got from Nashville City was the very raw data that operators submitted, and there was no aggregation or truncation of coordinates. So basically, we had a very detailed information, and basically that's one of the reasons why we were able to build a very robust model. And regarding the data privacy issues, there were no personally identifiable variables in the trips. This means like we were not able to identify who took those trips, or we even didn't have a user ID to say that this many trips were taken by an individual person. And I guess like they are very sensitive data, but we can also think in a way that, let's say if there's a population density of 1 person per square mile, and there's always e-scooter trip starting and origin at that location, then it's pretty obvious that the person living in that house is taking the scooter trips. But whereas in the high density area, it might be very hard to identify an individual who would be completing those trips. And I guess Stephanie can add on this.
Yeah, so similarly, when we ingest data through MDS, it is not truncated. Well, I think there are specific requirements on what is included within the trip data and MDS. But, you know, it is specific enough to pinpoint the location of the start and end of a trip. So when we aggregate data, we are sensitive to this. So even if we show like OD pairs, we don't show OD pairs that have less than 5 trips for the selected time period. And again, with the route data, we aggregate it to the street segment. So you can't see a full route, but you can still see volumes across the segment. I think for cities that use the data, so some cities do ingest the raw data. And like I know for the city of Chicago, they have an open data portal and an open data policy. So they ingest the raw data, and then they take that data and they aggregate it according to their open data portal standards, so that they can publicly share the data, but in an aggregated form. And in that case, they do it, I might be misremembering because I've looked at a lot of open data portals, but I believe they have it by like census tracts. They'll aggregate start and stops, or OD pairs, but they will drop it, I think it's at a 3-trip minimum. Or they have a way of dropping pairs that has, you know, fewer combinations for that selected period. I think I might be misremembering, but they do something similar in terms of dropping trips with low count, so that you aren't potentially identifying an individual. Like Nitesh said, if you're looking at areas where there's only, you know, like 1 house, or it might be easier to re-identify. So there are, I would say, kind of more common ways that cities and aggregators are looking at aggregation. But it is, and we do that because this trip data is potentially personally identifiable.
Okay, yeah, thanks, that makes sense. So we've had some couple questions come in through the chat or the question pod, so I appreciate that. Kristen Nordback has a question: is e-scooter use replacing walking trips, driving trips, transit trips, or generating new trips? So I know, Nitesh, one of the things that you pointed out was looking at the potential for mode shift, but I guess either of you can maybe address this question, what you're seeing maybe specifically in Nashville and also nationally.
Thanks. I'll take this one. Yes, the question about, like, you know, what modes are e-scooter trips replacing is very interesting questions, and we have hard time saying with certainty that, you know, these trips are replacing these trips. And with existing research, there are like survey-based research, there are micromobility data analysis research, and basically each of these approaches asks question in a different way. For example, for surveys, they might ask, like, for all the scooter trips in past week or so, what mode did you replace? But we need to, like, consider, like, there might be a lot of trips, and e-scooter trips might be even replacing multiple moves. So I think there is a lacking literature that identifies those replacing or even adding new trips for sure.
Yeah, I would agree. I think, oh, go ahead. Okay, I would agree. I think, yeah, it's really hard to know. So you can't really tell that from the MDS or GBFS data because you don't really know the choices that people are making. You can generally see where they're going, and maybe you can make some assumptions in that way. Like, there are a lot of questions that cities want to know about first and last mile connections, like are scooters and shared bikes providing a first last mile connection to transit. But it's still hard to make a conclusion about that. Even if you can see that a lot of trips are starting or ending around major transit centers, you don't know if they're making those connections. And there's a lack of that connectivity between these different modes that prevents us from really being able to tell that. You know, we and some cities have used surveys to try to fill those gaps, but even then, like, the data is not perfect. So we can see that, you know, some people are saying they are replacing walking trips and driving trips or generating new trips, but the data is still pretty limited, I would say, and I think that's definitely one place to grow, like Nitesh said, in terms of our understanding of what's really happening and the choices that people are making and how that's changing the way that people are making their transportation decisions.
Thank you for that. So another question came in from Samuel Musser. What is the typical revenue stream for operators? Are the cities that subsidize user fees in order increase use of e-scooters and reduce trips on other modes? Are there cities that subsidize user fees?
Yeah, so I'm not sure that I can speak to the revenue stream for operators. I mean, they are usually charging by trip, or maybe they have some subscription-based things. I could speak more to the subsidies. So there hasn't been a lot in this space. So I do think that cities maybe are getting closer to thinking about how to subsidize trips if they're trying to, you know, encourage certain behavior, like taking it as a first last mile solution. I know that in the Sacramento region that there was an effort to subsidize I think they were jump bike trips for those that were making a connection to transit. But I'm not sure that I have heard of any other implemented programs like that. But I do think that that could be coming. I think a lot of cities are still in the, like, wrapping my head around this mode stage. But I think if they, you know, are committed to having shared micromobility as an option, that maybe that does become something that they think a little bit more about and start to implement. I could see that.
Nitesh, do you have any thoughts or anything to add on how things work in Nashville?
I'm not sure about the financial structure of shared micromobility in Nashville, so I guess I would rather not comment on this.
Okay, thanks. I don't know about revenue streams either, but I'll throw out another example that I heard related to bike share. Several years ago in Pittsburgh, I was there for a conference, and I remember because of their interesting geography, in order to help with the rebalancing and redistribution of the bicycles across the network, I think users actually got some sort of you know, either fee reduction or credit or something like that if they biked their bike back up the hill to the other side of the incline. But that's been a while since I've heard about that. I don't know if they're still doing that, and I don't know if that relates to e-scooters as well. Those are all the questions that have come in. We can wait just a few minutes longer to see if there are any other thoughts that our audience members happen to come up with. Nitish, I had a specific question for you on one of your graphs where you showed the temporal distribution, you talked about a few things that gave context to the variations that you saw in the different clustering, particularly around the start and end of school and with the NHL draft coming. I was curious, there was another bump in the nighttime entertainment cluster that was right around January, I believe. It looked like it was maybe before school started, and I was wondering if you had any ideas of what that might be about.
I think, again, like, it's hard to say for sure. We can just make inference. And I think it's mainly tourists visiting Nashville in Christmas or New Year time. So that might have increased those nighttime entertainment district trips.
Oh, yeah. Okay, that makes sense. Good.
I have a question for
Okay.
Nitesh, because I'm curious.
Yeah, go for it.
I know that you mentioned that because the data set that you're getting from Nashville it's not MDS. It sounds like it's pretty similar, but it's different. So I was wondering about, for the principal component analysis, if you did have access to MDS in multiple cities, would the principal component analysis look very similar across those cities, or would they be specific to each city?
I would say like each feature uses Fair to specific to cities. So since Nashville is more tourist oriented, so we might see those kind of trips. And for example, Austin or even other cities might have very different. But in general, these methods apply to all the cities, and any differences in like even principal component analysis or k-means clustering can explain like those differences. Did I answer the question?
Yeah, no, that makes sense. That's cool.
Okay, well, if there's no further questions, I'm going to turn it back over to Zach to close us out.
All right. On behalf of ITE, I'd like to thank our speakers, Stephanie and Nitesh, for taking the time today to present. And that brings us to the conclusion